So this is our first Year 10 video for the year, kicking off the Algebra and Linear Functions topic. This is quite a big topic that I tend to break into 3 separate sections. So a sort of general algebra review, then coordinate geometry, and then simultaneous equations. So this first section is just reviewing some basics of algebra. So obviously algebra involves the use of pronumerals or variables, which are letters used to represent numbers, or unknown quantities, which are numbers obviously. Products or quotients. Okay, so product is multiplication, quotient is division. So when we are multiplying or dividing numbers and pronumerals, what happens when we do that is we form something called a term. So 3x is 3 times x, that's an algebraic term. Negative 4x squared y, that's negative 4 times x squared times y, that's an algebraic term. It's a product of letters and numbers. Okay, x divided by 5, that's a quotient of letters and numbers, that's an algebraic term. It's actually also products and quotients, you know, x divided, it can be thought about as x divided by 5. It could also be thought about as 1/5 times x. So they're essentially the same thing. You can think about any quotient as a product. And then when we take the sum or difference, so sum being adding and difference being subtracting of 2 or more algebraic terms, we create something called an algebraic expression. Okay, so 3x minus 5y squared, there's 2 terms in that expression. Okay, we're adding or subtracting the terms. And then in a term, the number is always written first, and the number is called the coefficient of the pronumerals, the coefficient of the term. Okay. For example, in the expression 3x minus 5y squared, 3 is the coefficient of x, and negative 5 is the coefficient of y squared. Algebraic expressions that involve an equal sign are called equations. Okay. So we essentially start with a pronumeral, or a letter, a variable representing a quantity. We might have a product of 1 or more variables that then becomes an algebraic term. Okay, we might then add that together with another algebraic term, and what we have there is an algebraic expression. And then if that is equal to something, it is now an equation. Okay, so just being really clear about that terminology. It's really important. I'm going to frequently throughout this topic and others throughout the year take you back to your basic understanding of numbers. And actually, any problems that you're having with algebra will fundamentally be issues that you have with the number work, where you're not thinking clearly enough about what it is mathematically that's actually happening. Okay, I'm really not a fan of, you know, shifting things around and moving things and these sort of rote learned processes where you're not actually thinking about what it is that you're doing with the numbers or with the algebra. It makes it very hard to then extend those ideas to other things. So it's really important that we understand our order of operations, and I know that seems really trivial, but it will create all sorts of problems if you're not thinking clearly enough about it. Okay, so BODMAS or BIDMAS is probably the most common way to learn the order of operations. Americans tend to use PEMDAS. Okay, I'll interpret that in a second. So these first 2 letters tend to have different, you can use different letters there depending on how you refer to them. We tend to use BODMAS or BIDMAS here. B is for brackets. O, if you learnt BODMAS, is not for of. Okay, lots of primary school teachers teach that the O is of, that BODMAS is brackets of, division, multiplication, addition, subtraction. The O is actually order, and order is sort of an older way of talking about powers. So if we had, you know, 3 to the order of 2, that's the same as saying 3 squared. We don't tend to use that terminology so much anymore, which is why BODMAS is perhaps slightly misleading. And many people now learn BIDMAS, where the I is indices. Okay, so brackets, then powers, order, indices, whatever you want to call them. Then division and multiplication, they happen in the same order, so they can be written the other way around in the order. So it could be, you know, BIMDAS would be also a correct order. Similarly, addition and subtraction, they can happen in any order. Okay, so as I said, this PEMDAS is parentheses, which we don't tend to use so much here. Exponents, which is another word for powers. Multiplication, division. Obviously, you could have PEDMAS. You could also switch around the division and the sorry, mass. You could also switch around the subtraction and the addition, but most of them don't make very nice words if you do that, so very few people do that. Regardless of the mnemonic you use to remember the order of operations, you must know and understand your order of operations. That's what's fundamental. Okay, let's just practice an assortment of algebra skills here. So the first thing we're going to look at is substitution, which is a really straightforward concept, but the difficulty within it can sometimes be just simply dealing with the number work that results. So, as I said, pronumerals are used to represent numbers, so you could be asked to substitute numbers in place of pronumerals. So here we have an expression xy plus x divided by y, and we want to evaluate that expression if x is equal to 12 and y is equal to 1/2. Okay, so xy plus x divided by y is now going to be equal to 12 times 1/2 plus 12 over 1/2. Okay, so when we have a a fraction with a large, that straight line is called a vinculum. Implicit in that is brackets, okay? That line is essentially saying you do everything on the numerator first, so there's brackets around that, and then you do the division. Okay, so we need to simplify what's happening in the brackets first. There's a multiplication and an addition in there, so we do the multiplication first, which is going to leave us with 6 plus 12 over 1/2. Now I'm going to do something else at the same time. When we divide by 1/2, so 6 plus 12, I'm going to write that like this, divided by 1/2. 6 plus 12 is 18, and dividing by 1/2, dividing by a fraction is the same as multiplying by the reciprocal of that fraction. So we flip the fraction. So it's 18 times 2, and therefore it's 36. Okay, question 2. Evaluate x plus 5 over 3 if x equals 1/4. So x plus 5 divided by 3 is 1/4 plus 5 divided by 3. Okay, we're going to need, again, you've got brackets up there, so we want to do that first. We're going to need a common denominator to be able to add together that fraction and that whole number. So 1/4 plus 5 over 1 is the same as 20 over 4, and that's being divided by 3. Okay, so we've got 21 over 4, and we're dividing that by 3, which again, dividing fractions is the same as multiplying by the reciprocal of that. 3 is the same as 3 over 1. The reciprocal of 3 over 1 is 1/3. Now, multiplying fractions, we multiply across the numerator and across the denominator. However, I'm noticing a common factor of 3 first, so I'm going to cancel it down before I do the multiplication, and in fact then I'm just left with 3/4. Rather than going to 21 over 12 and then having to simplify it, if you can cancel it down earlier, that's what you want to do. Okay, example 3, evaluate 3x cubed plus 1 if x is equal to -2. Okay, so 3x cubed plus 1 if x is equal to -2, so that is 3 times -2 cubed plus 1. Okay, so 3 times, now -2 cubed is -2 times -2 times -2. So -2 times -2 times -2. Now -2 times -2, that's positive 4, and then we've still got that times -2, and so that's going to be -8. Okay, so we've done the powers first. Now we'll do the multiplication. 3 times -8 is -24, and then we can do the addition. -24 plus 1 is -23. Okay, and example 4, evaluate -x squared if, -x squared plus 5x if x is equal to -4. So -x squared plus 5x. If x is -4, that's -4 squared plus 5 times -4. Now, I want to be really clear about the fact that these negatives aren't cancelling out. The -4 has to be squared before we worry about this. This is a really common error, okay? When people are dealing with x squared and they substitute a negative into it, often they write -3 squared. And actually that's not correct. It must say this, okay? So if you've got -3 all squared, that's not the same as having -3 squared. It's really important that you understand that. I guarantee this is something we're going to talk about repeatedly throughout this year. -3 all squared means -3 times -3. So that's +9. Okay? -3 squared, the order of operations that's happening here, this is actually, the power is happening first. Okay? So this is actually -1 times 3 squared. This one was -1 times 3 all squared. So the brackets overrode it, so it was -3 all squared which meant it's negative 3 times negative 3, so positive 9. This one is negative 1 times 3 squared. Now the order of operations tell me I do the powers first, so that's negative 1 times 9, and so this one is negative 9. So it's really important that if you mean this, you write this, but if you mean this, you write this, because they're different, okay? They're not the same thing. So here, it's really important that I wrote it in brackets when I subbed in that negative 4, and I didn't just automatically go, oh, okay, so it's negative, negative 4 squared, oh, negative, negative, that's just going to be positive 4 squared, because it's actually not going to be that. Okay, so we do the powers first. So negative 4 all squared is positive 16. This negative is still here. Okay, so that's going to be negative 16. It's negative because of that negative sitting out the front. It's not negative because of the negative inside the squared. And then we've got plus 5 times negative 4, so that's plus negative 20. So it's negative 16 plus minus, adding a negative is subtracting. So negative 16 minus 20, which is negative 36. Okay, so I know that's simple number work, but you know, fractions in fractions, squaring negatives, all those things I know are things that that students commonly make mistakes with. So it's really important that we think a bit consciously about what we're actually doing. Okay, the next thing we want to look at is something quite straightforward, like terms. So we have identified what a term is. A term is when we have a product or quotient, but generally a product of numbers and letters. Okay, and two terms are like terms if the pronumeral parts, the letter parts of the term, are the same. It's really important to understand that 3xy and 3yx are like terms. Okay, this is 3 times x times y. This is 2 times y times x. Now, in the order of operations, it doesn't matter what order we do multiplication in, so this is exactly the same as 3 times x times y, okay? The order that those letters are written in makes no difference. They are like terms. 3x and 5x squared are not like terms. They've both got x's, but 3x is 3 times x, whereas 5x is 5 times x, okay? So that is not the same as that. Only like terms can be added or subtracted, and when they're like terms, we simply add or subtract the pronumerals as necessary. So example 5 here, simplifying 3a plus 6b minus 6a plus 4b, minus 4b. So the like terms are 3a and negative 6a. It's really important that we understand when we're working with algebra that the sign in between the terms, the addition or subtraction, is attached to the term that comes after it. You can essentially think about your expression as a series of building blocks that you're allowed to reshuffle in whatever order you want. Okay, so it suits me in this case to think of this as 3a minus 6a plus 6b minus 4b. So essentially, and I don't have to write this out, but essentially to group the like terms together, so that then I can focus on just simplifying those separately. So 3a minus 6a, 3 lots of a, take away 6 lots of a, leaves us with negative 3 lots of a. And then we have 6b minus 4b, 6 lots of b, take away 4 lots of b is 2 lots of b. It is probably customary, it's perfectly fine, we've answered the question at this point and we're done. It's quite common that if you've got one term that's negative, we tend to always write that as a second term, so we'd probably write this as 2b minus 3a. It just helps to avoid the negative getting lost off the start of the expression if it's written as the sort of joining operation instead. But both of these are perfectly correct and the same answer. Okay, question 6, we want to simplify 4fg minus 5g squared f plus 4fg squared minus fg. Okay, so again we have like terms here, 4 lots of fg, take away 1 lot of fg. Remember, we don't write the 1 in front of a pronumeral, so if it's just minus fg, that's 1 lot of fg. And then the other two terms are also actually like terms. They're not written in the same order, but they both have a g squared and they both have an f. Okay, so I'm not going to write them out together, I should be able to do that. So the yellow terms, 4 lots of fg minus 1 lot of fg leaves us with 3 lots of fg. And the green terms, negative 5 lots of g squared f plus 4 lots of essentially g squared f leaves me with negative 1 lot of g squared f. So I wouldn't write the 1, okay, I just write negative g squared f. Okay, then we want to look at multiplying and dividing algebraic terms. So whilst we can only add and subtract like terms, any two terms can be multiplied or divided. And that's because a term is already made up of multiplication and division. So if you're doing, 2x times 3y, well actually this is 2 times x times 3 times y. It's all just multiplication. So we can multiply together the 2 and the 3 and get 6 and have xy. Okay, so any two terms can be multiplied together, but only like terms can be added and subtracted. Alright, so let's simplify example 7. Simplify 7a times negative 8b. Okay, so as I said, it's really just 7 times negative 8, which is negative 56, times a and times b. So again, we're just choosing to reorder things as it suits us. 7 times a times negative 8 times b. It actually suits us to do 7 times negative 8 first, because we can simplify that into negative 56, and then it's just a times a times b, which, can't do any more than times a times b. So I'm trying to erase that highlighter, and it's erasing everything else except. Okay. Example 8, simplify negative 2a times negative 9a. Okay, so negative 2 times negative 9 is positive 18, and a times a is a squared. Alright, simplifying here, so we're looking for common factors in the numerator and denominator. So 7's a common factor. We wouldn't write out this step, but what you're really doing in cancelling is saying that that's 7 times 3 lots of a, and this is 7 times 5. So what we're doing when we're cancelling a fraction, we'll talk more about algebraic fractions in a subsequent video, but we are making sure that we are dividing both the numerator and denominator by the same thing. Okay, it's really important that when you cancel, I hate the word cancelling, because you're not thinking clearly about what mathematical operation is happening here. So we can cancel those 7's because we are dividing the numerator and the denominator by 7. And so we're just going to get left with negative 3a on 5. In this one, okay, this is a times a, and this is 4 times a times a. Divide by a again, and we're just left with, now we don't have nothing on the numerator. Remember, a times a squared is one lot of a times a. Okay, so we actually have 1/4 left here. Alright, expanding brackets, some simple expansion. We'll look at some more complex expansions in the next video. So the distributive law is when we have one term outside a bracket of 2 or more terms, and the term outside must be distributed across the terms inside the bracket. So we have to do a times b plus a times c to get our expansion. Alright, so let's use that here. So 2/5 times 15x. Okay, again, I don't want to write 30 on 5 if I can help it. Okay, I know that 1/5 of 15 is 3, and so therefore 2/5 of 15 is 6. So that's going to be 6x. And then we're going to have minus, now remember this is 4 over 1, the 4 doesn't cancel down with the 5 at all, so there's no simplification I can do here, so it's just 2 times 4 on the numerator, which is 8, over 5 times 1 on the denominator, which is 5 8/5. So much of what we're looking at in this early algebra section, the key strategies, these should all be things that you're very familiar with. What we're really trying to do now is work on being able to do these things as efficiently as possible. Okay, moving forward, particularly heading into maths methods, these are really just fundamental skills that should just be as familiar as adding and subtracting. Okay, so we shouldn't even have to think about them, and so what we really want to work on is trying to be as efficient as possible. So thinking efficiently through that number work. I don't need to write that as 30 on 5, because I can essentially what I did there was cancel down the 5. Okay, you could think about it that way. Or actually what I did, as I said aloud, was I know that 1/5 of 15 is 3, and so therefore 2/5 of 15 is 6. Okay, expanding out here, so again the term outside must multiply everything inside, so we're going to need 3 multiplications. It's negative 4p times 3h, so that's negative 12ph, or hp, however you prefer. Generally speaking, we probably write them alphabetically, but it doesn't really matter. Negative 4p times negative p, so it's going to be positive 4p squared, and negative 4p times positive 1 is negative 4p. Alright, question 9, expand and simplify. So here we've got 2 brackets, and we have to be really careful about this. Okay, we want to think about this as being negative k times this whole bracket. This is a common error that many students would make, not expanding out that second bracket correctly. So the first bracket is easy enough. K times k is k squared. K times 5 is 5k. And then we've got minus k times k, which is minus k squared, and minus k times minus 3, which is positive 3k. K squared minus k squared, they cancel out, and 5k plus 3k is 8k. Alright, the last algebraic technique we want to review in this video is factorising by removing common factors. Factorisation is the reverse process to expansion, so we're essentially taking something of this form and going back to this form. That's the process of factorisation. So expanding, going in this direction, factorising, going in this direction. Okay, so what we're doing is we're looking for a common factor. So if we were expanding this, the common factor here is a. We take that out and we work out what's left when I divide each term by a. AB divided by a leaves me with b, and AC divided by a leaves me with c. Okay, so let's work through these examples. So we want to fully factorise negative 6x squared minus 15x. Now if both terms are negative, we would definitely factor out the negative as a common factor. We're thinking about negative 1 is a common factor. It's bigger than negative 1 though, because 3 is a common factor to both 6 and 15. So negative 3 is the numeric common factor. And then there's also an x in common in both of those terms. So if we take negative 3x out, and when we say take negative 3x out, what we're actually doing is dividing each term by negative 3x. Okay, so one of those x's will cancel with that, the negative 6 and the negative 3 cancel down to be 2. Okay, so 2x. You should also be able to check it, because when you multiply it back, negative 3x times positive 2x should give you negative 6x squared, which it does. Okay, negative 15 divided by negative 3 is positive 5, and we've divided out that x, so it's just plus 5. Okay, question 7, we're looking for common factors. Okay, so there is no, sorry, that should be a squared. Let me just correct that, that's an error on my part, otherwise they're like terms that we should collect together. There's no numbers in common here. Okay, 2 and 8 have a common factor of 2, but it's not common to 3 as well, so there's no number that will factor out. And there's x in common to all of them. The highest power of x that's in common is just the x to the power of 1. So we'll take out x, and when we do that, we're going to be left with 2x squared minus 3x plus 8. And that's as factorised as that will go. Actually, well, the quadratic might factorise further, but we're not interested in the quadratic factorisation just yet. We'll review that a little bit later on. Just trying to think, factors of 16 add up to negative 3. I don't think it will factorise further, so I think that's fine. But yeah, I'm not too worried about the quadratic factorisation yet. We'll review that down the track. Okay, questions 8 and 9, we want to really be able to see, to do this more efficiently by identifying an interesting common factor here. So what a lot of students will do is they'll expand out those brackets, they'll collect all the like terms, and then they'll factorise it. And actually it's going to make for something much, much harder. It will be a quadratic expression, which, as I said, we'll review factorising quadratics further down the track. That's not what we want to do here. We want to actually identify that in both terms, what is common is the bracket. Okay, the first term is x times that bracket, and the second term is negative 3 times that bracket. So if we take out that bracket as the common factor, so that whole thing is the common factor. And when we take that out, when we divide the first term by x plus 1, we're just going to be left with x. And when we divide the second term by x plus 1, we're just going to be left with negative 3. Okay, so fully factorised, x plus 1 times x minus 3. As I said, expanding all of that out and then factorising it back again is much less efficient. Alright, again, what we want to identify here is that essentially this first term is x plus 2 times x plus 2, that's what x plus 2 all squared means, and then it's plus x times x plus 2. And again, we want to identify that actually what's common to both these terms is the bracket x plus 2. So when we take that out, so we're taking out that bracket, we're going to get left with, so from this first term we're going to get left with an x plus 2, and from here we're going to get left with an x. Okay, so we're going to have x plus 2 and then plus x. And then obviously there's some like terms in there that we could collect together to simplify fully. So x plus 2 times 2 lots of x plus 2. and actually I've introduced a complication that I didn't mean to, but while we're here, let's talk about it. This actually isn't fully factorized because this bracket now still has a common factor. So what we have here is that x plus 2 still, and then we've got multiplied by, this is 2 lots of x plus 1. Now, as we've talked about previously, conventionally a number gets written at the front, okay, and so we would write this as 2 times x plus 2 times x plus 1. Okay, because remember, this is all multiplication. The order that we do them in doesn't matter. I'm going to choose to write the 2 first, and then the x plus 2, and then the x plus 1. We could write those brackets around the other way. It's the same thing. Okay, but just conventionally, the number on its own should go at the front. Okay, so your CAS calculator. Let's just think about a couple of things that we've talked about here. So simplifying, so that is collecting like terms, expanding and factorizing, and actually even earlier than that we looked at substitution. Let's go back and have a quick look at that. You probably wouldn't use this technique for these sorts of simple expressions, but there's lots of cases over the next 3 years where being able to substitute a value back into an expression is nice and easy, so is really helpful. So I'm just going to have a quick look at, I'm going to put my expression in brackets, okay. Control divide will bring up a fraction template. So I'm just looking at example 1. Let's just illustrate how to do that. Now, x, it's really important, we'll talk about this in a minute in some other examples, it's really important that we type in x times y, okay? Otherwise, if I just type xy, my CAS thinks that it doesn't distinguish. If I write a number times x, it understands, if I just write 2x, it understands that that means 2 times x. But if I write ax, it doesn't understand that that means a times x. It thinks I've got a variable that is called ax, okay? It allows me to use words. So if you've got 2 letters next to each other and you mean them to be multiplied together, you need to be explicit about that. X times y plus x divided by y. Okay, and then outside of that, I'm going to use a given that symbol. Control equals. This vertical line we read as given that. So we want to evaluate this expression given that x is equal to 12, and we need to actually type the word and. Now we could do that manually by pressing space and then typing and pressing space again. Y equals whatever it is, half. Control divide for the fraction template, 1/2. The alternative to manually typing the word and is to go to the book, which is to the right here next to the number 9, and that has every single function the CAS can do. So and is nice and easy to find quickly here. If you type a, it'll take you to the top of the list, and look there, the third one down is and, so you can get it from there as well. And it will substitute x equals 12 and y equals 1/2 into that expression. Okay, as I said, if I hadn't typed x times y, it would have a problem because it wouldn't recognize that that's x times y. It would just think that's xy, and it doesn't know what xy is. So you'll see it still has xy written in the expression. Okay, so the given that is a really useful thing for substitution. Okay, so again, if we look at example 4, let's put our expression in a bracket. Now, if you forget to type the bracket first, that will be okay in this instance. If I type negative x squared plus 5x and then close a bracket, it'll assume I meant to put 1 at the beginning. And then given that x is equal to negative 4, should verify that our answer is indeed negative 36. Okay, let's have a quick look at the other things highlighted in this box. So collecting like terms, there's no special instruction for that. Your CAS will automatically simplify an answer. Okay, so if you type in, 2x minus 5y plus 9x, 9x plus 7y, it will, and you just press enter, it will automatically simplify that. So in this case, that means collecting like terms. Okay, if you were to type in a fraction, an algebraic fraction, let's say 25xy over 5y. Oh, sorry, again I didn't put that multiplication between the x and the y, so it won't know what I mean. 25. So I want you to notice something here. So I just typed 25x, I didn't put in the multiplication. I've manually typed the multiplication between the x and the y. I haven't bothered to manually type a multiplication between the 5 and the y. When I press enter here, it'll simplify it so it won't show you, but it'll insert multiplication symbols. So look at the line above. When I typed 2x minus 5y plus 9x plus 7y, I didn't type in any of those multiplications. My CAS will insert them where it thinks I intend them. So if you notice that there's not a multiplication sign between, when I press enter, that happened. If you notice there's not a multiplication sign between some two things that you meant to be multiplied, then your CAS isn't understanding that they're being multiplied. So if I press enter here, you'll see on the left hand side it's reformatted the answer I typed in to insert in the missing multiplications that I didn't type in, so the one between the 25 and the x and the one between the 5 and the y. If I hadn't typed in that multiplication sign between the x and the y, it wouldn't have inserted one for me. Sorry, so even if I hadn't typed in that one either, it would insert the ones between the 25, after the 25 and after the 5, but it wouldn't insert one between the x and the y. It doesn't assume that that's what I mean. Okay, but going back to the correctly typed in version, it will simplify that fraction point. I haven't done anything other than type in the expression and press enter. It will always give me the answer in simplest form. Okay. We can expand brackets, so menu 3 for algebra and 3 for expand. Don't use the arrow keys to navigate the menus, get used to the number combinations. Menu 3 for expand. Again, being careful about, if it's 4x times, if you don't type this multiplication in. The difference here is your CAS will understand that you meant to type a multiplication. The bracket's triggering something for it. If I press enter here, it will say invalid implied multiply. It knows that I meant to put a multiplication somewhere around where that bracket starts, but it doesn't know where to put it. So I need to tell it I want it to be in there, and then it will understand. Okay. Similarly, factorizing, menu 3 for algebra and 2 for factor, and then type in whatever the expression is that you're trying to factorize. The example in that screenshot is 12x squared minus 10x, and press enter, and it will factorize if it can. Okay, so any of these basic algebraic things can all be done with your CAS. I'm not saying it's more efficient to do them with your CAS. I'm not asking you to do them with your CAS. I actually want you to do them by hand. But what I want to do as we review these by hand algebra skills is to just show you how the CAS can do them, because it's really important that we're aware of what our CAS can do so that we can make good decisions about CAS. Okay? As I said, it's not quicker to factorize using CAS often. Very rarely would I use factor in my CAS, but it's important to know that it can do it for those moments when you think, oh gosh, that's ugly, I wonder if my CAS can help me here. Or you might be using it as part of something else, okay? So it's important to be aware of what your CAS can do. Okay, the work today is from exercise 1A. It looks like a long list, but it's because I've just tried to cut things down a bit. LHS referring to left-hand side, RHS referring to right-hand side. So just doing a single column in each of those questions.